Okay, this problem is one where we have a ball, and the ball is being thrown down, and the ball ends up falling. The initial velocity is unknown, but the ball falls for a certain height, and that height is 3 meters. The ball hits the ground with a final speed at this point of 8 meters per second. Okay? Now we need to figure out what the initial velocity of the ball was. The way we're going to do this problem is use energy. We're going to say that the initial energy is equal to the final energy. Now, the initial energy of the ball has two components. It has the height of the ball, which is mgh, plus the kinetic energy of the ball, which is 1/2 mv squared. And that's going to equal the final energy of the ball. Finally, down here, where our position is 0 meters, the ball has no gravitational potential energy. It only has kinetic energy at the bottom. And so that's 1/2 mv squared. Final. Now, in order to solve this problem, we're going to have to solve for the initial velocity. We have the final velocity, we have the height by which it falls, and so we can solve for this using a little bit of algebra. And so we can say, alright, 1/2 mv initial squared is equal to 1/2 mv final squared minus mgh. And then we'll multiply everything by 2 and divide by m. We can cancel out our m's right now. And we end up having vi squared is equal to this 2 multiplied over here, it cancels this 2, and so we're left with v final squared minus 2gh. Now, for those of you that have studied kinematics before, you'll notice that this is a very common kinematics equation. Finishing the solution, we get vi is equal to the square root of vf squared minus 2gh. Now, if we plug our values into that, we end up having vi equals the square root of 8 meters per second squared minus 2 times g times a height of 3 meters. And so therefore, we end up with an answer of 8 squared is 64, and so 2 times 9.8, 3 times, subtract, and take the square root, and our answer is 2.28. So the original velocity of the ball up here when it was thrown down is equal to 2.28 meters per second. And that's the end of this problem.